This is the homework helper for Chapter 12, Section 6 in the 8th grade workbook, Graphing Inequalities in Two Variables. Alright, so let's go ahead and take a look at the first one here. Y is greater than or equal to 2x plus 3. So remember, you want to graph this just like you would graph it if it was an equation, something with an equal sign. So since this would be like in slope-intercept form, what we want to do is go ahead and graph it like it's slope-intercept form. So since the end here says plus 3, I'm going to put a dot on the y-axis at 3. And then my slope here is what's in front of x, 2, like 2 over 1. So from this point, I'm going to go up 2 and go over 1 and connect my points. Now, you have to remember, when we're doing inequalities, you have to graph lines in a certain way. When the symbol here has one of the lines underneath, it's graphed with a solid line. When it does not have one of the symbols underneath, it's a dashed line. So this is going to get graphed with a solid line. Okay, so now what you want to do is your shading, because graphing it is only part of it. We have to show now where all the different answers are that satisfy the inequality here. So remember, what's the best point to test when you're going to do this is 0, 0. And you can test 0, 0 anytime the line does not go through 0, 0. What you want to do here is go plug 0 in for y and 0 in for x and see what happens. You're either going to get a true inequality or a false inequality. If you get a true inequality, you're going to shade where the point is. If you get a false inequality, you're going to shade where the point isn't. So when I go up here and change these guys into 0 and 0, it's going to say 0 is greater than or equal to 0 plus 3, or 0 is greater than or equal to 3. In case you're not seeing where this 0 came from, 2 times 0 is 0, which is how this changes just into 0. So when I changed it to 0, 0, I got 0 is greater than or equal to 3. Well, obviously that's a false statement. Since it's a false statement, you're going to shade where the point isn't. The point is not to the left of the line, so I'm going to shade to the left of the line, and there's the solution to my inequality. Now, number 2 is not quite in slope-intercept form, but we can make it into slope-intercept form and work with it, or we can do the intercepts method. It doesn't really matter. I'm going to go ahead and change it over by adding 4x to both sides here. And when I do that, I'm going to give y is less than or equal to 4x plus 1. And as you can see, now that's in the slope-intercept form, or slope-intercept form like. It was not exactly slope-intercept form because it's not an equation, but we graph it the same way. We look at the end here, it says plus 1. That's my y-intercept. So my y-axis, a dot at 1. And then my slope here is 4. Slope of 4 means that from this point, I'm going to go up 4 and run 1. And from there, I'll go ahead and connect my points, connecting my points with a solid line because this is one of the ones that has the line underneath. Looks a lot like the last one, a little bit further down on the graph, but it's very similar. Alright, so now we want to go ahead and do our test of 0, 0. The graph does not go through 0, 0, so we can do that. So we're going to go ahead and do that here, change 0 and at y into 0 and x into 0. So that's going to give me 0 is greater than or equal to 0 plus 1, or 0 is greater than or equal to 1. Now that's a true statement. 1 is the bigger number there. So since that's a true statement, we're going to shade where 0, 0 is. 0, 0 is to the right side of the line, so this time I'm going to shade to the right side of the line. Alright, let's go ahead and take a look at question number 3 now. Question number 3, you got 2, and then you got parentheses, 3x minus y in the closed parentheses greater than or equal to 6. That's not really in any form that we would have anything to do with, so let's go ahead and manipulate this so it looks like something we would work with. So, since I've got this number in front of the parentheses here, that means I need to distribute. So I'm going to distribute these guys through, distribute the 2 through. 2 through to 3x is going to give me 6 x's. 2 through the y is going to give me 2 y's. It's still going to be greater than 6. Okay, well that's better. At this point, I can go ahead and change this into slope-intercept form, or I can just do standard form and spot the intercepts. Let's go ahead and spot the intercepts here. Remember, when we're doing intercepts method, one time through, you're going to let x equal 0, find y. The other time through, you're going to let y equal 0, and find x. So if I go through and let x equal 0, that's going to disappear, and it's going to say negative 2y equals 6. Well, we know that negative 2 times negative 3 is how I get 6. So my y-intercept is negative 3, meaning this graph goes through the y-axis at negative 3. Other way through, if I let y equals 0, well, that means this middle part's going to disappear, and it's going to say 6x is greater than 6. Well, that means 6 times 1 is how I would get 6. So x is going to equal 1. So my x-intercept point is at 1. Now, as you can see, this one does not have the line underneath it symbol-wise, so when I connect my points, I'm going to go ahead and use a dashed line here. And then I've got to go ahead and do the shading. Again, the graph does not go through 0, 0, so let's change x and y into 0 and see what happens. It doesn't matter really where you do it here. You can change your x and y's into 0s here, or you can change your x and y's into 0s here. Let's just do it here. That'll make this guy go to 0, this guy go to 0, so it's going to say 0 is greater than 6. Well, 0 is not bigger than 6. That's a false statement. So since it's a false statement, I'm going to shade where the point is not. 0, 0 is not to the right of the line, so I'm going to go ahead and shade to the right of the line, and there's the graph of my inequality. Finally, we'll take a look at number 4. Y is greater than or equal to 3/4 x minus 1. So this one is in slope-intercept form like 1 and 2, so we'll do the exact same thing. The intercept here, well, at the end it says minus 1. So I'm going to go ahead and put a dot on the y-axis at negative 1. Then I'm going to go ahead and plot my slope. My slope here is 3/4. So slope of 3/4 means from this point that I'm going to rise 3 and run 4. Up 3, right 4. And so when I do that, I end up over here at 4, 2. Then I'm going to connect my points with a solid line because this is one of the ones that has the line underneath the symbol. It's greater than or equal to. Now I got to test my point here. Again, it's going to be 0, 0 because the line does not go through it. That's the only time you can't use 0, 0 is if the line does go through it. So I'm going to go up here and change my x's and y's into zeros and see what happens. So I've got 0 is greater than or equal to 0 minus 1, or 0 is greater than or equal to negative 1. Well, that's a true statement. Since it's a true statement, I shade where the point is. That point is above the line, so I'm going to go ahead and shade above the line. And there's the graph of my inequality.